Okay, everybody should be able to access the stream from that. Okay. So yeah, we're having a competition at Wiki. I think everybody pretty much got all the info there, but there's no limitations on who can join the competition at Wiki. If you've competed in XFC, that's great. We encourage everybody to do so. I would also like to thank a few people in particular, Dr. Barnabas Spade from DigiPen for encouraging students to participate and donating his time in seminars. Similarly, Scott Dick from the University of Alberta, he served on our judging panel. He gave us the XAI criteria that we base some of our evaluations on. Also donated time by giving seminars related to XAI. He also uses a similar Kessler-based competition in his classes. And we know that some of the students have gone on to compete in XFC. Jai Fan, one of the competitors actually this year, he's identified and corrected several bugs in Kessler. Nick Ernst from Tallis, he's promoted and sponsored XFC from its inception. And also Zach Phillips from Tallis. He's the main author of Kessler, and he leads efforts to make it more user-friendly and efficient. And also Kelly Cohen at the University of Cincinnati. He's promoted XFC since its inception and encourages his students to participate as well. So that is the intro. Right here we have the playoff bracket as it stands with the seeds, and the format that it'll take is we first have Neo versus the Amulets. The winner of that will then play the winner of 360 No Slope and Fuzzifiers. And the winner of that second match, the second round, will be the winner. Then we'll also have second place, the runner-up from that. And then we'll also have another match between the ones who don't make it to the final to determine third place. But now we're going to go ahead and do student presentations. So I have two recorded presentations, one from Team Neo and one from Team OMU. We have allocated about 10 minutes for their presentation plus Q&A. So if anybody has questions, you can put them in the WebEx chat, the Teams chat, and I'll read them. Or if you're in the Teams chat, you can unmute, but just make sure that if you do so, you have your live stream muted if you have it open. So first I'll go ahead and share the presentation from Team OMU.
Hello, my name is Eric.
Okay.
Hello, my name is Eric, and I'm presenting the Team Omelets submission to the Explainable Fuzzy Challenge on behalf of Ayato and myself. We are both students at Osaka Metropolitan University, hence the team name Omelets. Pictured here we have the first draft of our sprite, the flying space rice omelet. I was pretty happy with this one, but some of the details like the words pew pew didn't translate well in game, so we had to spruce it up a little bit. The core approach to our agent was to include three distinct behaviors. We have the sniping behavior, which aims for the nearest asteroid, the navigation behavior, which tries to find an area to sit in with low asteroid density, and I'll explain what that means later. And we have the collision avoidance behavior, which just tries to avoid imminent death and move away from the nearest asteroid. And which behavior we use at any given time is based off the distance to the nearest asteroid. So, sniping is activated if the nearest asteroid is 200 or more units away. Here we have just a simple hard-coded algorithm where we select the nearest asteroid, and we ask, where will this asteroid be in 0.1 seconds? Can I get a bullet there within 0.1 seconds once I account for the time it takes to aim and the bullet travel time, etc.? And if yes, well, I'll shoot that location in 0.1 seconds. If no, well, what about in 0.2 seconds? And this is basically the algorithm. It's a for loop. We don't use 0.1 seconds. We use 1 frame, 2 frames, 3 frames, etc. But that's how it works. Navigation is the most intelligent part of our agent, and this occurs if the nearest asteroid is between 100 and 200 units away. Our approach is to create a radar-like view of the area around the ship. We divide space into 12 subregions, all relative to the front of the ship. So for example, this region right here is the middle front region, which contains anything within 45 degrees relative to the nose of the ship, and between 100 and 250 units away. Under the hood, we convert the asteroid Cartesian coordinates to polar coordinates, which makes centering things relative to the ship really easy, as well as calculating these subregions. Then for each subregion, we calculate the asteroid density, which is just the sum of all the asteroids centered within that region, divided by its area. And our goal was to create a fuzzy controller which can use this information to navigate towards the low density areas. So our controller consists of a series of fuzzy rules. The rules take the radar information as input and output the hopefully appropriate action. So for example, if the front middle region density is high, then we want to full reverse. The asteroid density is matched to fuzzy sets. We used 5 fuzzy sets, low, low medium, medium, medium high, and high, and 3 crisp sets, don't care, which is always equal to 1, clear, which is equal to 1 if and only if the density is below 10%, otherwise it's 0, and dangerous, which is just the opposite of clear. We discovered candidate rule sets through genetic algorithms. The fitness of each rule set was evaluated by actually playing the game with a fuzzy controller derived from that rule set. We used a series of custom benchmark scenarios and calculated how long each controller survived. Controllers also received a bonus for time spent in low-density areas. Collision avoidance occurs if the nearest asteroid is less than 100 units away. Unlike the navigation behavior, which tries to navigate towards safe areas, the goal of this behavior is just to avoid an immediate collision. Ultimately, we found a simple algorithm that worked both well and is highly intuitive. If the nearest asteroid is behind us, run away. If the nearest asteroid is in front of us, face towards it and floor it in reverse, since this is a little bit faster than trying to turn around and run away that way. Finally, I'll talk about one lesson we learned, which is the value of wall clock time. We were both quite busy with other commitments until maybe April 8th, a week before the submission deadline. And 1 week of crunch time seems really good until you factor in the relatively slow iteration speed of working in machine learning. Right? You want to tweak some parameter, or you want to change the fuzzy sets we use. It takes 4 hours until we can even see if the results have any effect on the results, positive or otherwise. Which meant our navigation controller was kind of neglected, and we didn't get to train it for as long as we'd like. But it is what it is. So thank you so much for your attention. Thank you so much to Timothy and crew for organizing this challenge for us, and I'm very excited to see what the other teams have come up with.
Great. That was a great presentation by Team OMU. Does anybody have any questions for Team OMU?
I have a question. So, I saw your team last year's competition, and it looks like you made a lot of changes, and I really enjoyed the presentation. And my question, apologies if I missed this part, but how do you decide which of the controller modes that you use? So like navigation or avoidance or sniping. Is that a fuzzy set system?
Can you hear me?
Yes, we can hear you.
Okay. Please give me a few moments to answer. Our controller is divided into 3 mechanisms, and it depends on the distance from ship and nearest asteroid. If distance is 200 or more, the sniping controller is on. And navigation controllers occurs if the nearest asteroid is between 100 and 200 units away. And if the nearest asteroid is at less than 100 units away, collision avoidance controller is occurred. That's all.
That makes a lot of sense. Thank you.
Thank you.
I also had a quick question for Team OMU, which is, did you consider other approaches besides genetic algorithms?
No, we considered genetic algorithms, and firstly, we tried to use reinforcement learning with deep neural network, but the result was so bad, so we use simple fuzzy controller and simple genetic algorithms.
I see. And I assume it would have been a reinforcement learning approach with the deep network.
Sniping controller and the collision avoidance controller is hard-coded, and navigation. Do you think we use reinforcement learning to which controller?
No, I just meant about the deep learning method or the other architecture that you talked about a second ago, but that's okay.
Okay, thank you.
Yeah, thanks a lot. I also want to thank Team OMU for actually being here live. It is currently very early in the morning or late at night, depending on your perspective in Japan. So thanks for being here.
Thank you. It's 3 a.m. now, so I'm so sleepy.
Oh, wow. Man, thanks for being here.
Thank you. Thank you.
Okay, so now we're going to show Team Neo's presentation. They also have a recorded one. And then we'll also have a few minutes afterwards for Q&A with Team Neo.
Hello, I'm Jai, and I'm really excited to be here. I've got to thank Dr. Scott Dick from the University of Alberta for introducing me to this.
The sound is not working?
Yeah, I couldn't hear myself there at least. Hello, I'm Jai, and I'm really excited to be here. I've got to thank Dr. Scott Dick from the University of Alberta for introducing me to this in his class. Neo started as a last-minute group project, and I had so much fun that I'm here. So this is a very brief overview, and I'll have a deep dive video on the XFC YouTube channel where I go into the code and explain things in more detail. Alright, so this game is deterministic if it wasn't for the other ship. And basically my strategy is to try a bunch of actions and pick the best one. So you know how chess AIs kind of look many moves ahead and choose the best one? It's like that. A simple controller might work by taking in the game state each time step and outputs actions. The controller lives entirely in the present. Neo works differently, and I guess it transcends time. It ingests the initial state, looks into the future, works ahead on simulating the game state, and bases planning on the future. It's like streaming the video you're watching right now, where the video is buffered seconds into the future.
I rewrote the Kessler game within my controller, and when debugging, most of the time when something mismatched, it's because I made a silly mistake. But a few times, I ended up finding and fixing bugs in Kessler because I wrote my code differently without those issues. It can even play the whole game blind. It's like memorizing a Rubik's Cube and then just solving it blindfolded. But of course, if there's another ship, then that's like solving a Rubik's Cube blindfolded while your friend is messing with the cube. It's just not gonna work. So in that case, Neo has to open its eyes every now and then. So anyway, we can try out moves without committing, but we still need controllers to do the moves, which is why we need a way to evaluate which moves are good. I use a quasi-fuzzy fitness function to evaluate states and actions. Reward good stuff, punish bad stuff, and balance the two. Fuzzy logic is good at deciding the high-level stuff, so I use it as a heuristic to guide my random search and to decide whether it's worth laying a mine. Neo is an action planner wrapped around a simulation module, and inside we've got a bunch of tools and 2 controllers. We either stay put and spray bullets everywhere, or we maneuver around, shoot asteroids, and come to a complete stop again. For maneuvering, I'm just randomly moving, and I have a fist that heuristically suggests moves and another basic learning mechanism in there. So as an example, let's say I'm being closed in on. I'll just randomly move here and crash. Bad fitness score. Crash, crash, crash. But then by chance, I escape. Good fitness, decent fitness, and good fitness. It's random search, and during the scenario, I'll learn and adapt stuff so it narrows down the search space just like a GA. Targeting controller. So first we need an aimbot, and then to do target priority with another fitness function and stuff. So let's just try to shoot directly at the asteroid, and it missed because we didn't account for the asteroid moving. So we consider the asteroid moving and do some more math, and we get the angle to shoot at, and we calculate it, aim, and we still miss because we didn't account for the time it takes to turn the ship, and the correct shooting angle changed in that time. So it's Zeno's paradox. You can do some iterated search or binary search with the math, but alternatively, we could do more math. So account for the turn delay with a system of equations, do some algebra, and we get some transcendental stuff that we can't even solve, but we can find its derivatives, chuck it into a root finder, turn the crank a couple times, and bam, we've got an aimbot. So even if we have perfect targeting though, there's still this annoying thing where the bullet can skip over the asteroid. And this happens pretty often. So maybe the solution is to do some math, but nah, just kidding. Let's just simulate it. Yeah. My adversarial strategy is to mostly play defensively. And Python's kind of slow, and I need this to be really fast, so I rewrote Neo and statically typed Python and compiled it to a C extension. For training, I threw Neo on all my computers, did a bunch of training, shot 2 billion asteroids. And I really hope Neo's not sentient, because stuck in a space simulation, dreaming of asteroids for 10,000 years. I used a GA to optimize the weights of my fitness function, and intuitively I first hand-picked some values, but then the optimized values are just way different than mine. And 2 factors I thought would be important are just completely unimportant, because they came out with weights of 0. I spent a lot of time debugging, but I do find it kind of fun, and I enjoy the challenge. I also made a visual debugger to show some cool stuff. There's some more potentially optimal stuff that I decided not to add, such as corner camping and closing ring freezing. So feel free to steal those. I'm pretty happy with Neo, and it's already pretty good, and it'd take me many hours to close the gap to optimality by even 1%. I learned a lot from this. First, big thanks to ChatGPT. I also learned that code can work surprisingly well even with major bugs, so I got better at finding as well as fixing bugs. And I learned that hard-coded AI is very hard to code, and if this was more complex and if there was uncertainty and sensor noise, this approach would become totally intractable. And that's it. Reach out if you have questions. Take my ideas. I also have Neo and fun scenarios on my GitHub page you could play with. So, yeah, thank you.
Great presentation. Yeah, in terms of Neo becoming sentient, maybe we'll just add more things to Kessler so it doesn't get bored. But I'll go ahead and open it up to everybody else for questions first. I see Leo has a question. Go ahead, Leo.
Yeah, how's it going? It's Leo from DigiBen. Yeah, I just had a question for you, G. Like regarding the fitness evaluation for like evasion of asteroids, how did you handle essentially the game scenarios being constantly dynamic? Like you basically getting different roles of the game every time you start the game. Like, did you like recode the game to basically keep giving you the exact same scenarios so that you could actually train on it?
Great question, Leo. So the GA is all done in real time. So just within the game, Neo is essentially dreaming of possible things that could happen to it, and then it evaluates the scenarios on the simulation so that it can kind of predict the future and just think, if I go over here, oh no, I'm going to crash. Let's not do that. So it just thinks before it does actions. So we're not restarting the game at all. The GA is completely done in real time. Nothing is stored. No persistent training is done. Does that answer?
Okay, yeah, that makes more sense. You're literally just evaluating every course of action as opposed to letting the agent like try it and then see what results.
Exactly. Yeah, it's very computationally expensive. So like half of the time I spent was literally just optimizing my code just to get everything faster.
Yeah, that makes a lot of sense because essentially we ran into a similar issue when we were training of just not being able to like reproduce the same environment or state enough for the agent to actually be consistent.
Yeah, that's fair. So I will also add that my agent is non-deterministic. So for debugging, I have to use a set seed so that it behaves the same each time, and I'm able to catch those bugs. So I think it's really useful to first use the random module to generate a random seed, and then you set the seed with the seed you just generated. So you could print that out to the debug log and repeat your scenarios.
If nobody else has any more questions, I do have one or two. Jai, you mentioned, because the game's deterministic, you can predict the state. And you did mention sensor noise and the other agent, injecting non-determinism. How would you potentially modify your approach if it was more non-deterministic?
Yeah, really good question. Like, for example, if the asteroid splitting was non-deterministic, or if there's like uncertainty. So there already is some uncertainty I handle in the actions of the other ship. And the way I do that is basically just pretend that everything is deterministic, but check for major mismatches in the states. But if there were more uncertainty, I think I would have to use potentially like I don't know exactly what I'm talking about here, but maybe like a Monte Carlo search approach where I'm accounting for all the possible things that could happen. Like, for example, if an asteroid's going to skim right by me, maybe the asteroid does actually collide with me instead of skimming right by me. So I might have to consider stuff like that. I could pretend the asteroids are bigger than they actually are to give myself some buffer. Or if the asteroid splits are non-deterministic, maybe I can simulate a few, like I could just throw a bunch more computing power, maybe simulate 100 possible asteroid splits, and just to get like a probability distribution that I could then base my actions off of. Yeah, it's a great question. Are there any more?
Yeah, thanks for that. Does anybody have any more questions for Jai?
I see Sam's typing something. How are we doing on time?
We're doing okay. We have about another minute if we have another question. Okay. If anybody has questions for the student teams, you can reach out to the organizers of the competition, or if the student teams don't mind, you can reach out to them directly. We're going to move on to the next presentation. Leo, does 360 No Slope have your presentation ready?
Yeah, we can go ahead and present right now.
Okay. If you don't mind sharing your screen.
Is that working?
Yep, looks good. Leo.
Sorry, I guess.
Yeah,
Sorry, give us a second. It's on another screen. We're trying to figure out how to swap it over.
Oh, no worries.
All right, technical issues. You guys all see the presentation now?
Yep, looks good.
Cool. Hey, so we're Team 360 NoScope from DigiPen Institute of Technology. I am a junior, and
I'm a senior. I'm Garrett.
Just diving right into this. Oh, there we go. All right, cool. So basically, our approach to this problem set. So the game of asteroids basically has two distinct tasks, right? You want to shoot asteroids, and you want to also be able to survive incoming asteroids so you don't get killed. Shooting is pretty predictable through use of linear algebra. I mean, like we covered before, you can basically make your calculations to get the exact ship and asteroid movements, your shot trajectories and placement. And essentially, we decided it was best to handle that just using a hybrid finite state machine and flexible rule-based approach, because that's pretty direct. Whereas survival is going to be more ambiguous. You have a lot of noisy data in the environment. Ship doesn't necessarily know what is most relevant at all times. There's different like gradations of danger. So our original intentions were to train some kind of fuzzy inference system with a recurrent deep queue survival controller. That didn't actually work out, but we will get into that.
So our initial architecture that we experimented with, we decided that the shooting controller would be best just to do a greedy target selection, just based on acquisition time. That would give us the most amount of asteroids in the shortest amount of time. We used a fuzzy rule base to approximate the optimal turning rates, target acquisition, etc. And for our survival controller, this was a much different problem. We wanted to test, or we did test, a lot of DQ learning models, doing a lot of different extensions and transformations to that, none of which pulled to fruition, which we'll cover later. But we did a ton of feature engineering for certain parameters to pass into that model, and then our action space varied a lot using different combinations of turn rates and thrust in order to survive.
Basically, so in the process of training our DPU learning stack, we realized probably around like the end of this, or I guess January, February timeframe, that we had nowhere near enough compute to realistically get the actual results we wanted, and we'll get into the reasons for that later on as well. So we made some drastic changes, basically to try and cut down the game environment, just simplify it, conduct as much dimensionality reduction as possible. We did things probably a little bit unorthodox, but it still kind of works. So we'll get into that. So first thing we did was we actually discretized the actual game space. So as opposed to the actual continuous game screen, which you see with all the continuous variables like velocity, positions, etc., we actually converted the game screen into a grid type system, and then we actually localized even further the grid system. And we'll actually have a demo here. It'll make a lot more sense. We also basically, instead of using all of the features of all the game objects, your asteroid positions, velocities, radius, heading, etc., we basically use a abstracted embedding system. So we basically take all the data that's in the game, try and use a fuzzy rule base to make sense of it, and then we basically output a simple 2D tensor that just emulates a threat score for your entire localized grid space. We preserve temporal data using propagated thread. It's kind of maybe a little bit similar to what the previous team had as far as the plan look ahead. We essentially take portions of the threat score and propagate it forward based on the time step in the future it corresponds to. I think on our last build, we used approximately 90 frames, so roughly 3 seconds look ahead. And that preserves your direction of movement for objects in game space. And then finally, we implemented an attention mechanism to weight essentially threats that are closer to the ship, as opposed to like maybe you have like 10 small asteroids and a corner that's going to be weighted less than like one large asteroid that's like much closer to the ship itself. Again, you'll see that in the demo we have here. And then finally, to actually handle the behavior itself. So we use finite state machines to actually interpret the localized embedded input space. We normalize the threat basically to enable the interpretation of the optimal escape vector, the conditions for the shooting controller inference, and also conditions for using mines as well. Basically, since we were able to simplify the problem to the use of discrete actions, the final handling can actually be achieved by the FSM, even though originally you had access to 480 x2 like versions of thrust, 180 x2 versions of turn rates. We basically just dramatically simplify the game environment and the actions the agent has available to it, solve that issue. And then this discrete input space also it'll improve explainability a lot, because we actually have now an ability to provide like a live like visual interpretation of the game environment.
Yeah, so this is just kind of a diagram of kind of how the state flows through our controller. We repeat the state, we discretize it, that gets passed to a threat grid where we then assess, okay, do we need to survive or do we need to shoot, or can we shoot in this scenario? And then the shooting controller takes in the continuous variables to calculate, to do trigonometry and linear algebra in order to calculate the exact position that it needs to shoot at. And yeah, so and then the survival controller, there's also a mine condition where places our quote-unquote optimal mine, and that's how we get our output. So for our learning, we use genetic algorithms to kind of just fine-tune our fuzzy rule base. We use our fuzzy rule base for our shooting controller, which optimizes turn rate. So when you're turning at maximum speed, you're going to overshoot your optimal target position by whatever amount of degrees. So we need to await basically a turn rate decay, and so we do that through our fuzzy rule base, and also assessing the best time to survive and tend to shoot based off of our localized threat score. We pass that through a fuzzy rule base. So yeah, then that impacts our target acquisition time, and then our optimal escape vector and our mine lane conditions. So
I'm not sure how laggy this is appearing on the stream, but this is a quick GIF showing the gameplay itself as well as the underlying grid system we created. Essentially, there's something called occupancy grids that are used in the autonomous vehicle stack that basically kind of inspired this. And you can actually see there, it's actually displaying the actual like fuzzy and propagated like threat values that are being calculated. You can see the ship is actually actively navigating towards the areas of the lowest threat membership, which is going to be your safest area. Basically with this controller, also just going into the results. So we have a controller pretty high accuracy for the most part. The calculations were direct, so no issues there. The survival controller does have a few failure cases that we'll go into. Basically, since it is immediate localized grid and is also based off a threat like membership score, even if you have severe weighting, there's still situations where like an asteroid that's like directly behind the ship will still get discounted, even though it's an immediate threat, because there just might be so many asteroids in the other directions that it still decides that that's still the best or lowest threat membership area to go.
360 no slope. You have 2 minutes left for Q&A.
Oh, okay, gotcha. All right, let's blast off this. Sorry, so key takeaways from this: reinforcement learning, super computationally expensive. We trained on a single i7 with an RTX 3070 and ran experiments approximately 1,500 hours training time. But realistically speaking, like state-of-the-art stuff, OpenAI 5, they trained for approximately 54,000 years of Dota 2, which is several orders of magnitude higher. Biggest thing we learned is break the problem in smaller pieces and try and go even smaller than that. I've tried to generalize the input space as much as possible so you can reduce the dimensionality and still make sense in the environment and take advantage of ways to optimize calculations through different types, whether it's numbers arrays, PyTorch tensors. You have to consider your CPU, GPU usage there. And just outline that, like when all those optimizations for our problem actually result in like over a 9% decrease in training time. So it makes a huge difference, even though we didn't quite complete all of our training. And let's jump into the Q&A here.
Okay, we have about a minute for Q&A, if anybody has any questions.
I've got a question if nobody else wants to ask. Yeah, for epic presentation. You can't hear this because I was muted, but I was saying wow like every 3 seconds. I'm still digesting things, but just a basic question is how computationally expensive is it to run that model once it's already trained?
Actually, after the training, it's not particularly computationally expensive, although I will say, like, if you're simulating a full 60-second game as a baseline, probably takes about a real 30 seconds, 35 second calculations. So it could probably be optimized a lot more. You just ran out of time to optimize the actual fuzzy calculations at the end there.
Okay, gotcha. So is it like linear in runtime compared to the number of asteroids, like O of n, would you say?
Yeah, if it's properly optimized, 100%, it's definitely.
Gotcha.
All right, thanks, Team 360 No Slope. Is anyone from the Fuzzifiers on the call? Okay, it appears they are not actually on the call. Well, we will get their presentation and we will get that put up on the YouTube channel at least. So with that, we will go ahead and move on to the competition. I'm just going to do a quick technical check on the stream to make sure there aren't any problems. Gotcha. Thanks for that, Barnabas. Okay. So with that, we're going to switch over and take a look at how these trained agents actually did. So again, our playoff is our first round. We have Neo against Amulets, and then we have 360 No Slope versus Fuzzifiers. So we're going to start with Neo versus Amulets, and I'll go ahead and show you the portfolio of scenarios we're training over this year. So we have some of the same ones from last year. We don't want to make it too hard on everybody. But to prevent some, overfitting, we have some new fun ones. The first ones that they will do, they're going to do some very small ones that have a few asteroids. Let me yeah, sorry, it was not being shared in the teams. It was only being shared in on the stream. Let me go ahead and do that. Okay. Okay, everybody should be able to see my screen now in both teams and on the stream. Again, the portfolio of scenarios we're going to go over. We have these first two, which are very small. And the second one is just the same as the first, but the positions of the ships are swapped because it's a non-symmetric scenario. So it's pretty small. They are going to just go around and shoot and see if they drop any mines, see what their behaviors are like. Then on, sorry, it looks like we might have a question in the chat. Then we're going to go into some more difficult scenarios where we have asteroids distributed around the screen in certain patterns. We will have walls of asteroids moving towards the ships, including one where the walls are closing in on them. We will also have a very difficult one where the wall is moving very quickly. We have some new ones that we've introduced this year, which are corridors, and essentially there's a corridor inside of a field of asteroids that are moving, and we're going to see how the ships behave, whether they try to get out of that corridor by blasting their way through it, or if they try to move with the corridor, etc. The first one, they have a lot of ammo. The second one, they have very limited ammo, but they do have more mines. So this one is more focused on the mine laying behavior of the agents. And then, of course, the last set of scenarios that we have here are everybody's favorite, the rings that close in on the ships. So we have one where the ring closes on one of the vehicles and not the other, and then the ships are swapped. So the other player gets put inside the ring. Then we have rings closing on both of them. Then we have a situation where we have smaller rings in terms of size of the asteroids, but they are closing very quickly on both ships. They're both inside the same ring. And then we have another one with the two rings closing on each of the, so there's two rings closing on each of the vehicles. So without further ado, we're going to go ahead and run matchup number 1, which is NEO versus OMU. Let's go ahead and do it. All right, so this is a pretty small scenario. We just have a few asteroids. We see that OMU went up to the top and is just sort of skirting around. Oh, NEO laid a mine. Took out a few asteroids there and laid a mine right next to OMU. Oh, and wound up taking a life from OMU in the first scenario. Now, they had limited ammo, so NEO's already actually out of ammo and mine, so he's just waiting for the sim to end, essentially. So the sim ended. This is the same scenario, but their starting positions were changed. We see NEO laying another mine to hit some asteroids. He's already out of bullets, so yeah, some interesting behavior pretty early. This one, we have a wall of asteroids coming towards both of them. We see NEO laying mines to collect score, although he wound up hitting some asteroids down at the bottom. OMU started moving around the wall to the bottom and is shooting towards them, and oh, interesting, okay. Shooting towards some other asteroids, not laying any mines though. And NEO still has a mine in reserve, but he's cleaning it up with his bullets. This one is a bit different because we just have static asteroids, so it's kind of interesting to see which asteroids the agents prioritize. OMU seems to be caught in some sort of situation where it's not reacting to the asteroids. This is another wall scenario coming from the bottom, pretty similar to the last one. We see NEO using his mines to both blow holes in that wall and collect more score, and also creating a nice debris field, shooting asteroids all over the place. You know, he mentioned creating an aimbot, and it looks like the aimbot's working. Really high accuracy levels. In this scenario, they have unlimited bullets. Oh, OMU just hit some asteroids and lost its last life. This is a fun one. We have the walls closing in on the two ships. So it looks like NEO got caught. He spent a life to blow a hole with a mine in the wall. OMU lost 2 lives right there. Oh, and OMU just died. That's unfortunate. Pretty heavy debris field. No noticeable slowdown, so some pretty good efficiency from the NEO controller. He still has a mine left, but he's focusing more on shooting the asteroids right now. But of course, the pretty small time limit on that scenario. This one's a bit different because the wall is staggered, and so part of the wall starts on the other side of the frame. So this one's really meant to check. Oh, it looks like OMU is trying to follow NEO around there. But this one's really meant to check to see if the agents can handle with wrapping very effectively or not. And both of them survived, wow. And then this one is a little bit more difficult because the asteroids start coming in at a much higher velocity initially. Again, NEO using those mines pretty effectively to gain score and kind of clear out a path in the wall pretty early and continuing to mop up with shooting. OMU seems to be a lot more focused on avoiding at the moment rather than gaining score. And so now we're in the corridor. This is the first corridor that's angled. So we see this field of asteroids kind of moving around, and Neo's doing a pretty good job of, kind of ignoring the corridor and just making his own. Why not gain score and clear out the field at the same time? Unfortunately, it looks like OMU got caught at the edge of the screen there and lost all of their lives. Neo's already used all of his mines. This one goes for a little bit longer. He's already out of mines. In the next scenario, it's the same as this. However, there's very limited ammo and bullets, but the ships have a lot more mines. So yeah, they start off with 10 mines, and Neo's already out of bullets, but he has a bunch of mines left, and so let's see what he does. He's going to have to try to avoid and move pretty smartly to try to get away from this field that's being created, especially because a lot of these smaller asteroids are moving pretty quick because of the momentum. A reminder that the mines actually do impart momentum on the asteroids based on how far they are from the detonation point. So doing pretty good. Some pretty good avoidance that we're seeing, Yeah. So now we have no mines left, and Neo is just avoiding until the end of the scenario. But wow, managed to survive pretty well. And now we've got everybody's favorite. We have a closing ring on Neo. He was able to set a mine and blow a hole in one side of the ring, and then set another mine that really created a nice big debris field with a lot of asteroids shooting everywhere. Now it looks like OMU didn't fare so well. No mines left, and so Neo's now just clearing out some of that debris that was created. The next one, now we have OMU inside of the ring, so we'll see what happens when he gets a bit closer. We'll see if OMU can get out of the ring or not. He already lost one life. Let's see if he can get out of there before his invincibility wears off. Oh, unfortunately, OMU couldn't get out of there. And we see some interesting mine placement. Yeah, clearing up some of the smaller asteroids, especially using the wrapping effectively, placing a mine for the asteroids about to wrap into it. And now this another scenario where they're both inside rings. These are very small rings, so a lot easier to get out. Oh, interesting. Neo set a mine and then stayed on top of it. It was towards the end of the sim, willing to sacrifice a life for it. And here we go. This one is a lot of fun. This is one where we have the rings closing in on both of them. Oh, Neo successfully blew a hole and got out. Oh, wow. Oh, Neo laid a mine and then kind of got caught a little bit and just stayed on top of the mine. But only lost one life so far. Let's see if he can manage to survive this really heavy debris field that was created by the mines. Unfortunately, OMU not able to survive past that the initial ring pass. Looks like Neo's in a good spot, sitting down in this corner, being able to carve out a little pocket and just gain score without having to move too much. Wow. All right, so that was Neo versus OMU for round one. I'm going to take a look at scores and bring that over in 1 second. Okay, so Neo was team 1 and OMU was team 2. So these are all the scenarios that it was running on. And we have our total score. So team 1 Neo had 3881 hits on asteroids, and team 2 had 292. Accuracy for Neo was 99.5 and 48.58 for OMU. And Neo had 4 deaths and OMU had 26. So yeah, kind of a fun opening round. We saw some really interesting mine placement. We saw OMU really prioritizing kind of moving around as opposed to shooting or mine placement. But hey, that's okay. You do have to move around and get into a good position. So Neo taking the first match. And so Neo will be advancing to the next round. So next we have Team 360 No Slope versus the Fuzzifiers. Both of these from DigiPen. So we have a DigiPen playoff. Go ahead and get this set up so we have those two playing each other. And after we run the playoff, by the way, I'll open it back up for some commentary from the teams and some more Q&A from everybody else. Let's go ahead and get started with 360 No Slope versus the Fuzzifiers. So the first rounds are pretty simple. We just have these a few asteroids. We see No Slope, prioritizing shooting it's already out of bullets. Did pretty well with 97% accuracy. Fuzzifiers seem to be rotating and trying to identify targets, maybe. Looks like maybe the shooting isn't exactly on. Not sure. Maybe there's something. It's not identifying that it wants to shoot. Not sure. Oh, interesting. 360 No Slope, not shooting at that asteroid until it was decently far away. But then this other one that came wrapping back into the screen, it started shooting immediately. Still pretty good accuracy. It got a lot of hits right there. It's already out of bullets, though. Still no mine usage from either of the teams yet. Let's see if that changes on some of the new ones. Oh, wow, some interesting behavior from 360 No Slope right there. Started off flying up to the top and shooting, although maybe that was an issue with identifying wrapped asteroids. Doing pretty well, staying out of the path. Fuzzifiers weren't able to stay out of the way of the wall, though, and already died. But No Slope seems to be able to stay out of the path of the wall pretty good and taking some shots here and there. Another interesting one, yeah, they prioritize that bottom left one. Now they're prioritizing top left, but kind of a delay before they started shooting. And it looks like Fuzzifiers still having a few issues with shooting where they're rotating and kind of taking pot shots. Oh, and No Slope actually slammed into the asteroid there after wrapping around. Interesting. Oh, and did it again. Slammed into the asteroid there. Looks like No Slope may have an issue or two with the wrap. Oh! No Slope slamming into an asteroid. I mean, it looked intentional. I'm not sure if that was the case. Maybe to gain score, you do technically get a hit on an asteroid for slamming into them. Of course, it takes one of your lives, so not always ideal to do that. Fuzzifiers having actually some pretty good avoidance right there. Still rotating around. But we're able to make it through that wall by squeezing through that gap. Oh, No Slope. Wow, it got caught on the edge by a couple asteroids. They hit one and then a shot and immediately got hit by... Oh, No Slope running into... Oh, wow, No Slope ran into Fuzzifiers and just sat on top. And unfortunately, we've seen this. Fuzzifiers controller's throwing some divide by zero exceptions. So it's not performing any actions when that happens. Seems like they're both trying to avoid at the moment. 360 No Slope already shot all of its bullets, so it's just trying to evade. But not laying any mines. I haven't seen either of these lay mines yet, I think. I'll have to check the recording. Interesting. Fuzzifiers couldn't stay out of there, and then the scenario did. No Slope again, avoiding that wall by wrapping. Oh, laid a mine. We do get a mine. Took out a couple asteroids there. And Fuzzifiers already dying. It looks like it was No Slope was anticipating that wrap by the wall with that mine placement, although it was a bit behind where the asteroids wound up being. Some pretty good shooting though. Pretty good accuracy. We're at about 80%. Ooh, we're getting some noticeable FPS drop with the oh wow. No Slope not handling the corridor too well and slammed into one pretty quickly. Fuzzifiers also seem to having some difficulties with the corridor. No Slope. Oh man. I should mention, for those not familiar, in Kessler, your invincibility does go away if you if you shoot while you're invincible, it removes your invincibility frames. And so that's why No Slope died right there, because it shot, even though it's invincible, it started shooting, so it lost its invincibility and got hit again. No Slope, although it lost a life doing it, was able to get out of the first ring pretty effectively. Fuzzifiers seem content to just not move and shoot pretty slowly and rotate again. We're still getting some pretty noticeable FPS drop. You know, No Slope did mention during their presentation that the evaluation can be pretty heavy. We're seeing that here. Maybe some further optimization would help that out quite a bit. Some pretty good shooting though. We're seeing some pretty good accuracy. Fuzzifiers just died. Now let's see if Fuzzifiers can get out of the ring successfully. It looks like they're going to lose a life doing it. They've already lost one. Oh, they lost 2 lives. Oh, they're dead. Unfortunately, Fuzzifiers couldn't make it out of the ring in time. No Slope seems content to just sit back there and pick off asteroids from the outside. Let's see if they can, how much score they can actually gain before the time limit. Only got about 5 seconds left. Doing pretty good though at managing their accuracy. Pretty good. Fuzzifiers seem to have some more issues in situations like this with asteroids coming directly at them. And No Slope was able to get out of the ring successfully, picking up a lot of score, prioritizing the score over by the other ship, which is kind of interesting. We have seen that in some of these scenarios. It's kind of interesting to see how the ships might prioritize asteroids near the other ship for whatever reason. Maybe it's because it learned that shooting them would, make life more difficult, more likely to kill. Oh, we see a mine placed over there by the other ship, but unfortunately we hit the limit. This is the much faster rings. Oh wow, we saw a couple mines laid there by No Slope at the very end, trying to gain score, but wasn't able to dodge very effectively. A pretty good mine right there by No Slope, although it lost a couple lives getting out of the ring. And unfortunately, Fuzzifiers already died. Oh, another pretty good mine placement. I wonder if it learned that behavior to place a mine in on one side of the wrap and then move to the other side of the wrap to avoid the blast from the mine. That's kind of interesting if it learned to do that. Okay, so I'll open up that and see what the results were from No Slope versus the Fuzzifiers. Okay, so Team 360 No Slope was Team 1 and Team 2 was the Fuzzifiers. So the total hits over those scenarios for 360 No Slope was 1215 and 181 for the Fuzzifiers. Accuracy almost 90% for No Slope on those. Pretty good accuracy on a lot of those. Yeah, not too bad. And Team 2 accuracy, the Fuzzifiers doing not too bad also at 77%. Although we saw they were pretty conservative about shooting. They seemed to want to sit there and rotate and maybe pick and choose their targets and would only avoid when they had to. So some interesting behavior there. 25 deaths for 360 No Slope and 32 for the Fuzzifiers. So 360 No Slope wins the first round, and they will also advance to the next round against Neo. And then also in the third place bracket, we're going to have the Omelets versus the Fuzzifiers. Okay, so let's go ahead and do third place first. So we're going to have the Omelets versus the Fuzzifiers, and we'll see if how those do against each other. So our third place match is going to be OMU versus Fuzzifiers. Let's go ahead and check out the Omelets versus the Fuzzifiers. See how they do. All right, the first scenario, OMU comes out flying, wrapping around. prioritizing that movement, and then identifying that ramp pretty well. Not too bad. And OMU is already out of bullets. Fuzzfires again seem content to rotate and shoot pretty slowly. Oh, OMU decides to slam into the Fuzzifires, taking a life from both of them. Neither one of them seem to want to drop mines, though. Interesting. OMU, again, racing around at the beginning of the scenario, getting a few shots, and then kind of settling down. Pretty good shooting, though, at the moment. And OMU is already out of bullets. Let's see if it finally decides to drop a mine. OMU not reacting in this one to the wall yet. Interesting. I wonder if there's something triggering that. Like it has a certain threshold. Oh, Fuzzifire is already taking a hit. Not able to avoid. Oh, almost avoided and got out of that, but not quite. Yeah, it seems like OMU's controller might have something where it gets stuck trying to avoid. Yeah, interesting. Interesting. This one is very interesting to see which ones they prioritize. Because there's a couple different strategies. You can sort of shoot at one of them while moving towards another to then lay a mine. If you're trying to, maximize your score gain per second. But it seems like a lot of them don't do that. In fact, even in Neo's controller, we saw it kind of prioritize further away asteroids when they're static like that. Kind of interesting. Fuzzifire's taking a hit pretty quick right there on that wall, unfortunately. OMU doing pretty well to avoid it, though. Although, again, it seems like they're kind of prioritizing moving away from a bunch of asteroids moving towards it. Unfortunately, Fuzzifire's already losing all 3 lives. OMU finally deciding to shoot. No, unfortunately, a bit too late to gain a whole lot of score. Now we see them, the wall's closing in on them. Oh, will OMU lay a mine? No. Oh, able to survive. Oh, the Fuzzifiers just lost their last life, but able to survive with 1 life left for OMU. Let's see if it can gain some score here before moving on to the next one. Only got about 8 seconds left. Oh, unfortunately, no. And OMU has some interesting behaviors at the beginning of scenarios where it tends to it wants to get within a certain range of the asteroids before shooting, and it also avoiding. It likes to, OMU slamming into Fuzzifiers there, taking a life from both of them. Yep. It does appear that OMU has some behavior built in, though, for identifying when it's in invincibility mode. Because once it got hit, it definitely didn't shoot again until it was clear. Yeah, it looks like it's maybe caught in its avoidance mode. Oh, here we go. In the corridor, OMU actually doing pretty good, able to back away from those shots, or from the initial position of the asteroids, although now it's, now it's stuck in the middle of the field and needs to move. Can OMU do it? Oh, unfortunately, no. OMU having some pretty good behavior so far. It's looking pretty good in the corridors, although it's not laying mines, which it's already out of ammo. Although it's able to avoid pretty effectively so far. Let's see if we can get out of there. Oh, unfortunately, no. Just got stuck in that field of asteroids right there. Oh, OMU unfortunately already losing a couple lives with the ring closing. Let's see if Fuzzifiers can gain some score here, since they have a decent amount of time and a lot of asteroids to shoot, but still being pretty conservative with shooting. And unfortunately, not avoiding nearly enough there to get away from those asteroids. So now we have the Fuzzifiers inside and OMU on the outside. Let's see if OMU can take advantage also and gain some more score. Now, unfortunately, the Fuzzy Fires already lost their lives too. So let's see if OMU starts shooting a lot faster. We've seen it shoot quite a bit, although it seems to only want to do that when it's trying to avoid asteroids coming up behind it. Yeah, like this. Very interesting. It was able to get a little bit of score there at the end. Oh, OMU almost carved out a path. Let's see if it can do. Let's see if it can get out. Can OMU get out? Oh, it lost a life. But it was able to get away by only losing one. That's in a pretty good spot. Fuzzy Fire's throwing some exceptions here. Unfortunately, not performing any actions. OMU not doing too bad. Getting pretty close to some asteroids, but moving around and shooting, gaining some score. Whew. Oh, Fuzzy Fire's already lost 2 lives on that one. Let's see if they can avoid some more. Oh, OMU slamming into them to take their last life. I don't know if that was intentional or not, but man, what a brutal move by OMU to take the Fuzzy Fires out of that scenario. Now we have the 2 rings closing on each of them. Nope, Fuzzy Fires already died. OMU already lost 2 lives. Let's see if OMU can. Oh, OMU survived. They were able to at least wait long enough in their invincibility frames to be able to get through that. Let's see if they can get a little bit more score. We have a pretty heavy asteroid field right now. We've seen OMU's avoidance do a couple good things, but right now it seems to be a lot more focused on shooting straight ahead. Wow, so some really interesting behavior we saw there. I don't know if that was intentional or if it was supposed to be an offensive action, but we saw OMU slam into Fuzzy Fires in one of those scenarios and take them out of the game because they only had 1 life left. Really interesting. So now we're going to take a look at the Team OMU versus the Fuzzy Fires and see how they did. So a reminder that Team 1 was OMU and Team 2 was Fuzzy Fires. Okay, so OMU, throughout all those scenarios, had 685 hits, and Team 2, Fuzzy Fires, had 176 hits. OMU, worse accuracy actually, but they did shoot a lot, and there were a lot of situations we saw where OMU was seemingly trying to avoid asteroids that were coming up behind it and just firing quite a bit in front of it. So the Fuzzy Fires actually had decently high accuracy, but as we saw, they're pretty conservative with their shooting. OMU had 24 deaths, and Fuzzy Fires had 36. Okay, so we have our first podium finisher. Team OMU. The 4 seed taking out the 3 seed to win 3rd place in the playoff competition. And so now, the big event, we're going to have Team 360 No Slope versus Neo for the final, for 1st and 2nd. Let's go ahead and get that set up. All right, so our final coming up, we have Neo and No Slope. Without further ado, let's see it. These first scenarios should be pretty interesting. We have No Slope. Yeah, we saw some interesting behavior there where it didn't want to really shoot at the other ones, and Neo's already out of bullets, but was able to clean up with some mines. Oh, they're both going after those asteroids pretty early. Neo laying some mines to kind of clean up. He's already out of bullets. No Slope chasing down that last asteroid. Can it get it? It doesn't seem to want to shoot yet. Maybe it's stuck in a mode where it doesn't want to or can't shoot. Neo has a mine, but seems to be avoiding placing that last mine, or one of his 2 last mines. Oh, almost a collision there. Wow, so neither one of them able to get that last one. Oh, Neo laying a mine. Kind of prevented No Slope from going further. I don't know if No Slope's controller took that into account. Oh, laying another mine, trying to force people away from the center of that wall right there. Really interesting behavior. we see Neo prioritizing the far away asteroids in this scenario. Kind of interesting. There we see it laying a mine. Wow, almost took one of its own lives, but was able to avoid it either by the wrap or by getting outside of the blast radius. Interesting. Now we see No Slope, getting close to that mine, but successfully getting outside that blast radius. Neo laying some more mines and getting a lot more score. No Slope, though, content to getting away from the mine, but slammed into an asteroid, unfortunately, and lost a life. Some really good shooting by both teams. Although, of course, what can happen in this scenario, like we were talking about, both teams slamming into each other right off the bat. No Slope kind of caught in the middle of this wall. Unfortunately, No Slope got caught in the middle of that wall and didn't get through. What I was going to say is that, we talked about that non-determinism, but if you start shooting at asteroids, but the other guy shoots it before your bullet reaches it, it can really result in some odd behaviors because, even if you account for shooting at a particular asteroid, that can cause some interesting behaviors. Some good mine play. Oh, Neo laid a mine where it looked like No Slope was going to run into it. I don't know if that was to try to catch the other ship or try to catch asteroids. We don't know. No Slope already lost a couple lives, though, but both able to survive. This one's a lot faster wall. No Slope already losing a couple lives. Wow. Some really fast asteroids, thanks to some mine placement by Neo, just absolutely blowing the field up. Still has a mine left, though, and about 10 more seconds. Let's see how much score Neo can get. Doing pretty good. Oh, and here we have the corridor. Wow, both of them laying mines immediately, trying to blow holes in that corridor. Neo successfully got away from it, though, while unfortunately No Slope caught a couple asteroids. It got stuck in that asteroid field right there. But Neo doing some good evasion and kind of carved out a little pocket, and now it seems content to kind of sit there in that pocket and not have to move a whole lot. It does have unlimited bullets in this scenario, but he's already out of mines. The field looks like it's sparse enough, though, that he's pretty safe at the moment. Reminder that the next corridor one, they have very limited bullets. Yeah, so not many bullets, but a lot of mines. Oh, unfortunately, kind of the same behavior from No Slope. It already shot all its bullets and then got taken out by asteroids. Neo doing a pretty good job, though, avoiding, laying some mines, getting to a spot where he can lay more mines and get more score. Still doing a pretty good job avoiding. Yeah, some really interesting behavior. We still got about 13 seconds left. Oh, and that's Neo's last mine. So the game doesn't end when they're out of mines. Currently, we don't have that setting on, but we'll see if Neo can survive for a little bit longer. Oh, and looks like he did. So now Neo's caught inside the ring. No Slope just sitting outside there, gaining score, not having to worry about it. Neo laying a couple mines and was able to get out successfully without losing a life. Already used all 3 mines. Interesting. Oh, No Slope lost a life. Oh, and lost another one pretty. Oh, No Slope. Already out of the game, backing into a few asteroids there, unfortunately. And Neo created a pretty dense and fast field, but it's already carved out that pocket. It's just sitting there. No Slope doing pretty good here, shooting at one side. Oh, is almost able to get through. Still lost a light. Oh no! Slammed into the asteroids while still shooting. It successfully got out of the ring, but then couldn't hang on after it just slammed into a couple asteroids while shooting right after that. Nothing too new here. Neo's pretty much in the same situation it was at the end of the last scenario. Let's see if they can get out of the ring effectively this time. We see that mine placement by Neo towards the edge of the rings. Another pretty good mine placement. Oh wow, that one took out the rest of that entire ring. Unfortunately, Neo couldn't get away there. Oof. No slope. Trying to shoot and gain score while those asteroids were just coming in at it. Pretty good mine placement here by Neo. Let's see if No Slope. Oh, No Slope's able to get out. No Slope sacrificed a life. Oh, Neo also sacrificed a life with a mine. Oh, unfortunately, No Slope got caught by some asteroids there and then caught another one after the wrap. Yeah, it looks like Neo placed a mine right there, basically on top of itself, and successfully blew a hole in the ring, but was willing to sacrifice a life to do it. Might be the densest field we have in these scenarios. We have a lot of asteroids moving pretty quick. Neo still has one mine left in about 8 seconds. Let's see if he uses it to try to gain any last second score. Oh, I guess not, but that's okay. Wow. What a fun run. That was a lot of fun seeing both those controllers, especially the cases where they seem to interact with each other. We saw a couple cases where both OMU and Neo slammed into the other ship. Not sure if it's intentional, not sure if it's an artifact from training. Either way, it's some really interesting behavior. Okay, so without further ado, the results from Neo versus 360 No Slope. So team 1 was Neo and team 2 is 360 No Slope. Neo had 3556 hits and 360 No Slope had 517. Accuracy for Neo about 96.5% and about 84% for No Slope. And 3 deaths for Neo and 28 for No Slope. There were a lot of situations with No Slope we saw though where it was being pretty aggressive with shooting, and there were situations where it had invincibility frames, but then it was still continuing to shoot and lost its invincibility, which then killed it. So, you know, maybe a simple fix with taking advantage of invincibility frames more might result in a lot more hits, because if you're able to withstand that and get away to survive and then start shooting again, you can really get a lot more score because, you know, that takes you out of the game pretty quickly if you do that. But still, some really good behavior and really good shooting by both teams. It's also some really interesting mine placement. The corridor, you know, I was rooting for No Slope there to get that mine to blow a hole in that little chunk in the corridor and then be able to move away. But unfortunately, it just got caught in that field and couldn't make it out. But yeah, that was a lot of fun. That was some really good behavior and some really good shooting by both teams. So let's go ahead and we'll move these into our first and second place slots. So congratulations to all of our competitors. That was a lot of fun. There were some really fun moments in there, seeing how they reacted to some really interesting situations, especially with the other ships in the game with them. So without further ado, our playoff winner is Neo, Team Neo coming in first, with the runner-up, Team 360 No Slope, and in third place, Team Amulettes. So that is it for the competition, the playoff competition. We will be judging the explainability and innovation in the next couple weeks, and the judges will be giving us their scores. We will relay all the information to the teams about your explanation and innovation results, along with prize disbursement information when we get there. But yeah, thanks everybody for participating. It's a lot of work to create these agents and get them to do anything of value, let alone be able to get in a scenario like that and actually survive and move around effectively, lay mines, evade asteroids, all these things. And like Team No Slope was talking about, it can get pretty complex because you have a lot of asteroids in a lot of these situations, and being able to account for all that is very difficult. So congratulations to our competitors for creating agents that were so effective. That was really good, and congratulations to our winners again of the competition. Yeah. I would like if the team members are on right now to if they have comments on their performance and what they saw. Um, I don't know. I would like to hear from you guys. Like, what'd you think about your agents actually playing the game versus the other competitors?
I just want to say that was some really exciting competition, and that was such a joy to watch.
I agree. That was a lot of fun.
And Tim, you did a great job with the commentary as well, the shoutcasting.
I appreciate that. I tried to put on my esports voice. Yeah, I totally agree. They're a lot of fun to watch, and I had to do a lot of testing, kind of crafting the scenarios, and I have to admit, that wasn't too hard of a task. Just watching them and seeing what would happen. So, yeah, it's a lot of fun for me too. Okay. Well, if nobody has any other comments or anything, if Team 360 No Slope or OMU, if you have any comments, feel free to add. But if nobody has anything else, that concludes the playoff portion of XFC 2024. And we will be evaluating the agents for their explanations. Due to the technical difficulties we had earlier, I'll have to stitch together some of the recordings, but the live stream recording and the presentations will be on the YouTube channel after I do some editing. And then also we'll have recordings of the explanation portion as well that we'll put up. And with that, we'll go ahead and close out XFC 2024. Thanks everybody for joining. Yeah, it's been a lot of fun. I hope everybody had a lot of fun and learned a lot. Thanks.